All right, let's see a quick example of some of the things we've just learned. In this example, we're going to assume that X has a Rayleigh distribution. A Rayleigh distribution is a named distribution we'll see a little bit of, but it won't be one of the big ones from this half of the course. But we have the CDF of a Rayleigh distribution. It's provided below. The CDF is positive, positive for all values of X that are positive. So not for negative values, then we get 0. Our first part of this question is to obtain the PDF of X. So the PDF of X, in order to get that, we can use a property that we found up here. So the PDF is going to be the derivative of our CDF. So I'm going to just put that here. Another note is I went ahead and I drew this CDF out for, just my own sanity. I find it quite helpful to draw CDFs out. And with this CDF, some things that I have noticed, as with all CDFs, the maximum it could be is 1. It's going to get close and closer and closer to 1 as we go towards infinity, but never quite touch it. And then once we pass 0, it will stay at 0. Okay, so we know it is the derivative of our CDF function. So we are going to go dx 1 minus exp negative x squared over 2. Now the derivative of a constant is just 0, so we focus on e to the power of negative x squared divided by 2. We're going to go ahead and use the chain rule for this. Now, e to the power of something, taking the derivative of that is kind of nice. That stays the same. Now we need to take the derivative of the inside, which just becomes negative 2 over 2 times x. And then we'll simplify it a little bit. exp negative x squared over 2. All this is times x. But we are actually not done yet. Just like a CDF, where it is defined to be a particular value in a particular spot, and then 0 in when it is not in that range, our PDF is similar. And it's also like our probability mass functions from before. This function, or PDF, is equal to this expression only for certain values of x, if x is greater than 0. And it is 0 if otherwise. So that would be the answer for our PDF. But now we want to calculate the next part of this question, which is calculate the probability x is greater than 2. So I have already drawn the PDF for us. It is this function here. When x begins to be greater than 0, it starts going up, and eventually it goes down with this very long tail over this way. If I want to find the probability x is greater than 0, I can use the PDF for this problem. So just as a little reminder, when I'm trying to find probabilities, I'm using this property. I'm integrating between a particular range. So I'm going to put that over here so I can remind myself. I'll go ahead and make it a different color because it's a reference. Now, that's our reference, but we want the probability that x is greater than 2. Now, that is not between two constants a and b like this. But oftentimes, when we see an expression like this, and it's not between two constants, the other constant is implicitly assumed. So this is the same thing as saying the probability that x is bigger than 2 and less than infinity, which is the maximum value that x can be. And we often don't write this extra bit, and we just assume that based off context, but you can if you would like, if it helps strengthen what you're doing. Okay, so we're going to go ahead and start finding that probability. So we take the integral from 2 to infinity, e to the power of negative x squared, 2 times x dx. To solve this, I'm going to go ahead and actually do a u substitution. So I'm going to let u be equal to x squared over 2. I'm going to do du dx is equal to 2x over 2, which means du is equal to x dx. All right, and I don't want to forget these bounds. I want to make sure they check out. Applying our function to 2, we see that it's still 2, and for infinity, plugging that in, it would still be infinity, so we're good to go there. So this stays 2 to infinity. Checking the bounds is probably one of my most common mistakes when I learned integration, so it's nice to just double check that. Okay, we have e. This now becomes negative u, and this whole term here gets replaced over here with du. Now this is a much friendlier integral to work with. Taking integration for something e to the power of something is always pretty nice. This just becomes 1 over negative 1 e to the power of negative u. And this is evaluated from 2 to infinity. So I'm going to do negative 1 e to the power of negative infinity minus e to the power of negative 2. E to the power of negative infinity is 0. So this just becomes, our negatives cancel out, e to the power of negative 2, which is approximately 0.14. All right, that was one way to do it. But oftentimes in these sort of questions, there's often another way to do it, or multiple ways to approach this problem. So I'm going to show one more option to do this. Probability that x is greater than 2. Now, that range that I'm trying to get, probability that x is greater than 2, is this tail area over here. And what I can remember about PDFs and PMFs is that if we take the integral from all the values in the support, this area of this function under the curve needs to be equal to 1. And with PMFs, it's the sum of all values in the support. So I can leverage that property and make this 1 minus the probability that x is less than 2. And again, we don't have to be too careful about the equals in the continuous case. Also, if you'd like, again, for completeness, or just to be a little bit more explicit, this is implicitly assuming that x is between 0 and 2, because past 0, the PDF is 0. Okay. The other thing I note is that this expression right here, well, this is related to the CDF. So the CDF, if we recall, CDFs gives us the probability that x is less than or equal to some value. So I can use property of CDFs here. So I'll write it in orange. 1 minus e to the power, and instead of x, I'm going to substitute 2, because that's the boundary I'm trying to integrate up to, or trying to evaluate the CDF up to 2. So this minus 2 squared over 2. And then simplifying, the 1's cancel out, the negatives also cancel out, they turn into a positive, it just becomes e. And then this is negative 2 squared. We have 4, so we get negative 2 again. Negative 2 squared over, divided by 2, and we have the negative sign, and we still get about 0.14 approximately. So oftentimes there's a nice little trick like this in the background that you can do.